Principal Component Analysis, PCA, a comprehensive guide. Principal Component Analysis, PCA, is a popular technique for dimensionality reduction and feature extraction. It is widely used in a variety of fields, including machine learning, data analysis, and image processing. In this video, we will explore what PCA is, how it works, and how it can be used to extract meaningful information from data. What is PCA? PCA is a statistical procedure that uses an orthogonal transformation to convert a set of correlated variables into a set of uncorrelated variables, known as principal components. The goal of PCA is to identify the underlying structure of the data and extract the most important features or patterns. How does PCA work? To understand how PCA works, it is helpful to first understand some key concepts. Variance. Variance is a measure of how spread out a set of data is. It is calculated by taking the sum of the squares of the differences between the mean and each data point and dividing it by the number of data points. Covariance. Covariance is a measure of how two variables are related. It is calculated by taking the product of the differences between the mean and each data point for both variables and dividing it by the number of data points. Eigenvectors and eigenvalues. An eigenvector is a vector that, when multiplied by a matrix, results in a scaled version of the original vector. The scale factor is known as the eigenvalue. To perform PCA, the following steps are typically followed. Standardize the data. The first step in PCA is to standardize the data by subtracting the mean from each data point and dividing it by the standard deviation. This helps to ensure that all variables are on the same scale and have the same units. Compute the covariance matrix. The next step is to compute the covariance matrix, which is a square matrix that contains the covariances between all pairs of variables. Compute the eigenvectors and eigenvalues. The eigenvectors and eigenvalues of the covariance matrix are then computed. The eigenvectors are the principal components, and the eigenvalues are the variances explained by each principal component. Select the principal components. The final step is to select the principal components that will be used to represent the data. This is typically done by selecting the components with the highest eigenvalues, as these components explain the most variance in the data. What are the applications of PCA? PCA has a wide range of applications, including feature extraction. PCA can be used to extract the most important features or patterns from a dataset, which can be useful for visualizing the data or for building machine learning models. Data compression. PCA can be used to reduce the number of dimensions in a dataset, which can save storage space and reduce the computational requirements of machine learning algorithms. Noise reduction. PCA can be used to remove noise or irrelevant information from a dataset, which can improve the performance of machine learning models. Overall, PCA is a powerful tool for extracting meaningful information from data and reducing the complexity of large datasets. It is a widely used technique in a variety of fields and has many practical applications.